Good morning, one and all. I'm Praveen Kumar, and I'm currently pursuing BTech third year at Aditya University. Today I want to make a practical demonstration and a clear explanation of my recent project called Multimodal Rack System with document and image analysis. So, without any delay, let's start the project explanation, and then we will go to the practical demonstration. Um, Yeah, first we'll read the task details. So, what I need to build a multimodal rack system for document and image analysis. Description. This is not a normal rack system. This is an advanced level rack system. Rack means augmented generation. So, it can be capable of understanding your knowledge base. I mean, your uploaded documents and all the data you have sent. So, what I need to build, I'll show you in the readme of this. A retrieval-augmented generation system that processes the PDFs and images to answer questions using both text and visual context via Google Gemini 2.5 API. It's a VLM I have used. You can prefer your own. So actually, what happening is a normal chatbot cannot answer for your documents. It cannot be able to process all these 10 to 15 documents at a time. So that it will be useful for only text to do text queries, but not for your knowledge base. I mean your PDFs, research papers, etc. So this application can be used in real world applications. For example, in an law firm, we have 10,000 plus documents. Actually, this capable for 10 to 15 documents. We can add more. For example, we need to fetch the data from images, text to table data of the PDF. It can be take so much of time. Or another use case may be in a hospital X-ray system. We need to predict from 10,000 plus X-rays so that it will be it takes a lot of time, and normal chatbots cannot be able to do this process. So this is an advanced level where it can also extract data from the text, images, and tables. So what this system does in a nutshell: extract text, embedded images, and table, embeds all contents using clip text and images in the same vector space. Here I have used the clip with B Fightwall a vector dimensional space where images and the text will be placed at same place. For example, if the image and text are related to the similar vectors, there will be more similar. I mean, there we have the vector embedding same values, and stores embeddings in ChromaDB with full metadata. Here I have used the local database, I mean, for vendor database as a ChromaDB, and retrieves relevant chunks across all modalities using cross-modal search. Here, this is the, I mean, unique feature of this project. It can search using the cross-modal search and generate grounded answers using Gemini 2.5 Flash with image context. So whenever retrieved the data, we need to check with the actual data. So that I have used the VLM as a Gemini 2.5 Flash with image context. It can answer for the questions. So coming to the tech stack I have used, I'll show you. Yeah. For PDF parsing, I have used PyMu PDF and PDF Plumber. PyMu PDF is used for extracting the text from page by page of the given PDF, and PDF Plumber is mainly used for extracting the tabular data. For example, it identify the tables when it encounters such as a border, and another thing is it will also show the tabular data in the form of text, but using a singular pipeline. You can see the symbol like this. It looks like in your system. Yeah, for example, there is a text in a tabular data. It will store as column 1, column column 2, and for the specific column it will store the data as value 1, value 2, like that. Here it is an example I have shown you. This is how PDF Plumber works, and stores the data as the text format. And OCR. OCR is nothing but It is used to extract the text placed inside the image. No binary dependencies, and it supports 80 plus languages. Embeddings. I have used the technology clip with a B32. So it can store the shared text plus image vector space in a 512 vector dimension space and vector DB. I have used the Chroma DB and it is in a local system, so no server needed. And LLM, I have used the Gemini 2.5 Flash. You can use other open source alternatives like Lava, and another thing is Salesforce Bclip, Bflip, and because I have used it is as a fast model, multimodal responses and works better for this type of projects. And REST API I have implemented using Fast API because it will be the automatic pydantic validation, and it is an async Python web framework, and it will generate the automatic documents. For example, localhost colon 8000 slash docs. We can get the interactive documentation. So that's it. Okay, let's go to the tour. Yeah, the server is in running state. This is the Chroma DB I have stored in the locally but not pushed it to Git. And sample documents I have attached 10 documents. Like attention is all you need. Wait a minute. I will install the extension. Yeah, it's still in working but not able to recognize this. Why it's not working with the extension? Let me fix that. Is there an option to open with? Yeah. So I have installed this open VS Code PDF extension so that we can able to watch the PDF in VS Code too. So I have attached nearly 10 documents related to this AI, and such as pre-training and pre-training of deep bidirectional transformer for language understanding. So like that, I have attached 10 documents so that it can be able to answer from this knowledge base. I mean this PDFs whenever we ask a question. Okay. And coming to the pipelines, here are mainly two pipelines. One is ingestion pipeline and another one is the query pipeline. Ingestion pipeline means what it will does is it will extract the data from the PDFs, for example, text, image, and tabular data, and stores all of them in the Chroma DB as a vector embeddings, and here in the embeddings. And this ingestion pipeline only the model will be loaded, the clip model. And in the retrieval model, I mean in the query model, we can use the retriever. What it will does is it will combine all the three results of the collections: images, text, and tabular data, and returns the response. So now Gemini will verify the ground truthness, I mean with image PDF citations too, with the metadata where the where it is located. For example, okay, I will show you in the practical demonstration so that you will be understand more well. So coming to the SRC source file, first one ingestion. I have written the document parser.py. So coming to the libraries, I have imported Fit. It's an library for the PyMo PDF, which is useful for extracting text, and PDF Plumber extracting text from the tabular data, and OS in order to make any file operations like that. Okay, here I have encoded some in the environment variables so that secrets are will not be exposed in the Git or GitHub, and Git will be not tracking that env file once if we add it in the .git ignore file. And yes, this is the extracted image path. It will be stored in this extracted images. Okay, first method we will be exploring is extracting text from the PDF. It will takes input as an PDF path. For example, this 1 to 10 documents it will be taken and returns a list of dictionaries. Because for every PDF it contains so much of data, we need to return the metadata too. I mean, for example, when an embedding is stored, we need to return that ID, uh, type of content, and which PDF and which PDF number and page number also it has to be stored in the metadata. So opening the document with the open and storing the PDF path name in the document name. For page number in range, I mean, we are iterating through entire document and storing the text. This is all Python basic knowledge. And once we have written the chunk, I mean taken the chunk means here the context content text metadata. I have told you source document, document name, page number, and content type, and chunk id. As I have told you, will return a unique id for each chunk. So all these text chunks we have written, initialize a list, empty list, will be appending that chunk. So like that we will be extracting images from the PDF and table at yeah, extract tables from the PDF. So that's it. Ingestion, where the starting point extracting data will be done. Once extracted, what will done? We'll load the clip model. Retrieval, no, embeddings. Yeah, model loader. All the importing necessary libraries, and we have used sentence transformers for storing embeddings. We need transformers. We have used the sentence transformers. So this is the code for embedding images and dimension. And I have already told you, this clip model will use the shared vector dimension space, so that once I will explain with an example. For example, yeah, okay, rise of sales in 2025. This is a type of data, and the image contains bar graph related to the sales in 2025. So both are related to the same content, so that they have similar vector dimension, I mean vector embeddings, so that it will be used to access, I mean stored at the same place, so that it will be useful for accessing when querying the data from the user. And next is the generator. We'll look at this in the answer last place, because it will be the responsible for generating the user query response. And have we seen model leader? Okay, ingestion completed. Vector chroma manager. Chroma it will does is stores the vector embeddings. So importing the necessary libraries, and we have set the chroma db path. So once we have collected the data, we'll embed them in the Chroma DB. For text collection, we have used the name text chunks, and image collection we have named as the image chunks. And I mean, from starting, I'm saying similar vectors means similar meaning. How it is measured? It will be measured using cosine similarity. It measures the angle between them, not the distance between them. So this the one. Adding text chunks, image chunks, and table chunks. Okay, we have completed all these things. Okay, let's check the retriever.py. Here it would what it will does is it takes the input from the, I mean query from the user, and searches all these things. We have created this search text collection and image collection, table collection, so that all these things, three things will be having at one place. This is called unified indexing: text results, image results, and all the things. and the threshold we have set it as 0.75. Okay, we are passing through the chroma results, and it will return the list, which list of dictionaries. So I have already told you that we will use the cosine similarity retrieving, and so not only retrieving, we will be sorting them. I mean, and sorting and fusing them. I mean, combining them. So that's it. I have shown you the. Yes, yes. Okay, let me show you the architecture of this also. Okay, I have already told you the architecture and Redmi 2 and requirements of TXT. I have already explained you. And I have also created automated tests, nearly 38 tests. They will be located in the tests folder. So here what it will do is will test the API, and as well as the ingestion. When extracting test it, whether it is correctly ingestion or not. So I forgot to mention the main point, the REST API endpoint, which is main.py. All the interactions will be done through this API only. So we are importing the necessary libraries, and this is the content we will be seeing in this app. We are creating the fast API app, and with the title multi-modal RAG API and description about that. And we have added the course middleware also, so that it will be accessible from any front end or any tool like Postman or anything, so that it will be able to send request from any tool or any front end. So that's why we have added the middleware in order to overcome the CORS error, cross origin resource sharing error. And for query request, we have initialized the query need to be string only, and n results may be 5. Query response, what it will be giving response. And in the endpoint of slash query, we have implemented the user can be able to upload their PDF and get answers from that. So what are the endpoints we have there in the root query, which is a post request, and ingest means user can upload the files, and as health of the API. So that's it. I think I have explained everything. Test files also. Okay, let's test with an example. So the server is running state. Not 3000. It's running in the 8000 port. So here is the description about our project. So message multimodal rag and docs. In the doc system, we can interact with our API. So this is the one. Where fast API itself is an automatic pydantic validation, and it will automatically give the interactive documentation system like this. So health check. Yeah, the application is healthy in state. Next, we will query our knowledge base with any request. So try it out. So you can also use curl commands, but for this I am using this. I will also show you the curl command also. Query, for example, let's see any PDF and ask questions related to that. So let's ask a question in this. So difference between the pre-training and fine-tuning. itself. And we can add as many features for this project also.